Now we're going to look a little bit more in depth at matrix multiplication and its properties. Unlike regular multiplication of numbers, matrix multiplication for square matrices is not commutative, but it is associative and distributive. So we're going to look in depth at matrix multiplication. What happens? What are the special properties that occur when we multiply one matrix by another? Before we jump into that, let's review some number theory, and that is the properties of operations, specifically the associative, distributive, and commutative properties. Given an operation, use this at symbol to define that operation, but that operation could actually be addition, subtraction, multiplication, division, or any other operation you define. If that operation is associative, then we must get the same result when performing that operation, as long as we keep the order the same. For example, if we have that operation at, and we have A at B at C, where B and C are grouped together, and if that A at B at C is equal to A at B at C, in other words, we've kept the order, but we've moved the groupings around. If those operations result in the same value, then we would say that the at operation is associative. If the result of the operation is the same, if we distribute the operation to its parts, we would say that it's distributive as well. Here's an example of distributive property. If A at B plus or minus C is equal to A at B plus or minus A at C, then we would say the operation, the at operation, is distributive. Finally, an operation is commutative if the result of the operation is the same, regardless of what order the parts are in. For example, if A at B equals B at A, then we would say the operation is commutative. So let's look at some examples of operations with real numbers. We're going to look at addition, subtraction, and multiplication of real numbers. And then we'll see how that compares to matrix multiplication as an operation. And we're going to look and see if addition, subtraction, and multiplication abide by the associative, distributive, and commutative properties. Let's look at addition. First of all, is it associative? Well, is negative 3 plus 4 plus 2 the same as negative 3 plus 4 plus 2? Yes. And this is going to be true of any addition situation like this. If we change the grouping but not the order, it is going to work. Therefore, addition is associative. Addition is also commutative. If we change the order of the numbers, negative 3 plus 4 is the same as 4 plus negative 3. Is subtraction associative? Is negative 3 minus the quantity 4 minus 2 equal to negative 3 minus 4 minus 2? The answer is absolutely not. Similarly, subtraction is also not commutative. For example, negative 3 minus 4 is definitely not the same as 4 minus negative 3. Multiplication, on the other hand, is a special operation that is associative, distributive, and commutative. Negative 3 times the quantity 4 times 2 is the same as negative 3 times 4 times 2. Multiplication is distributive. Negative 3 times the quantity 4 plus or minus 2 is the same as negative 3 times 4 plus or minus, depending on which one it is, negative 3 times 2. Finally, multiplication is commutative. Negative 3 times 4 is the same as 4 times negative 3. So is matrix multiplication have the same properties, associative, distributive, commutative? Let's see if matrix multiplication is associative. Let's pick 3 matrices. Let's just make them 2 by 2s to make life a little bit easier on us. We'll let A equal 1, 2, 3, 4, B equal 4, 3, 2, 1, and C equal negative 1, negative 2, negative 3, negative 4. If matrix multiplication is associative, then A times B times C is equal to A times B times C. So let's simplify things by finding out what A times B is. If we multiply A times B, and we use our rules of matrix multiplication, and I'll do this with you once, but if you're having trouble with this, go back to the previous videos on the actual process of matrix multiplication. So it's 1 times 4 plus 2 times 2 for element 1, 1. For the next element in the row, it's 1 times 3 plus 2 times 1. And then for row 2, element 1, it's 3 times 4 plus 4 times 2. And then 3 times 3 plus 4 times 1. When we add those together, we get 8, 5, 20, 13. That represents matrix A times matrix B. If we do a similar process for matrix B times matrix C, we get negative 13, negative 20, negative 5, negative 8. So with those quantities in mind, let's perform the multiplication of A times the quantity BC. If we multiply matrix A times this quantity we've already defined as B times C, and we use our rules of matrix multiplication, we get the result of the operation being negative 23, negative 36, negative 59, negative 92. Similarly, if we do A times B, which is this matrix up here, times matrix C, we get the same answer. Therefore, the key question, is matrix multiplication associative? Is yes. Now obviously a formal proof would require more rigor, but at this point, and we're going to say that matrix multiplication is most definitely associative. So let's experiment to find out if matrix multiplication is distributive. In other words, if we multiply A times the quantity B plus C, is that going to equal matrix A times matrix B plus matrix A times matrix C? So to help us find some of these quantities, let's figure out what B plus C is, and let's figure out what AC is. We already know what AB is from the previous proof. Well, through matrix addition, B plus C is equal to 3, 1, negative 1, negative 3. When we add matrix B to matrix C, that's what we get. When we multiply A times B, we already know we get 8, 5, 20, 13. We've done that before. And when we multiply A times C, we get negative 7, negative 10, negative 15, negative 22. So let's take those values and let's figure out what this left-hand part is. What is A times the quantity B plus C? So if you take a matrix A, multiply it by this thing called B plus C that we figured out, we get positive 1, negative 5, 5, negative 9. That's the result of the left side. Now, if matrix multiplication is distributive, then when we do AB plus AC, we should get the same matrix value. Indeed, we do, because when we add AB to AC, which we already figured out, we get 1, negative 5, 5, negative 9. So, is matrix multiplication distributive? Absolutely. So we're going to end our exploration with a study of whether matrix multiplication is commutative. In other words, if we change the order, will we produce the same result? Is A times B equal to B times A? Works for regular number multiplication. Intuitively, we'd like to think it works for matrix multiplication. Well, let's choose our same matrices. A equals 1, 2, 3, 4, and B is 4, 3, 2, 1. If we multiply A times B, we already know we get 8, 5, 20, 13. So if we reverse the process and put 4, 3, 2, 1 in front and 1, 2, 3, 4 in the back and multiply them, if it's commutative, we should get the same result. We do not. 4, 3, 2, 1 times 1, 2, 3, 4 is very definitely not the same. The result we get is 13, 20, 5, 10. So matrix multiplication, is it commutative? No. It defies our intuition. And that's going to have some big implications for us down the road when we're trying to solve matrix equations. But it is not commutative. So we explored matrix multiplication, determining that its properties are associative and distributive, but matrix multiplication is not commutative. You cannot reverse the multiplication process.